So let's continue with Luria Delbruck experiments. And we saw that he had seen some phage resistant E. coli cells, and he came across the two theories. What are the possibilities? If it is a spontaneous theory, it would be this, and if it was an induced mutation, it would be this. So at first, Luria and Delbruck, they struggled to come up with experiments to put this disagreement to rest. And Luria, he tried to measure the proportion of the virus resistant cells in growing bacterial cultures, but he seemed to get different results every day. And he was in fact totally confused with it. And as we all know, every new discovery might sometimes be due to serendipity, or something might give you an intuition, probably saying you that this is the way it is. So the same way here, Luria, one day he had a chance to encounter with a colleague at a slot machine. And not a gambler myself, I was teasing him about his inevitable losses when he suddenly hit a jackpot about $3 in dimes and gave me a dirty look and walked away. Right then, I began giving some thought to the actual numerology of the slot machines. In so doing, it dawned on me that slot machines and the bacterial mutations have something to teach other. This is what Luria mentioned in 1984. That is, one day when he was making fun of one of his colleague at the slot machine, that person was always losing at the slot machine. But at a suddenly he hit a jackpot. So that incident gave Luria a probable thing that might be there would be something random which happened in the bacteria, just similar to the slot machine. And that was an intuition that led him think further. So he did an experiment here. He took a 40 ml suspension of E. coli in a nutrient broth, and he distributed them into two equal parts, 20 ml and 20 ml. And this 20 ml culture was divided into 40 test tubes, 40 independent cultures in which every tube contained 0.5 ml of this culture. So you have E. coli here, and one portion is divided into 40 test tubes with 0.5 ml, and the remaining 20 ml was taken as a bulk culture in one. And what he did is 0.1 ml aliquots from each tubes were spread on 5 plates which are already been coated with phages. So here also all these cells are not exposed to the phage yet. So from every tube which we explained here, he is taking about 0.1 ml of the culture and spreading it onto the plate. And he finds that in different plates, you must about 200 plates they analyzed, and it is on this plate that the phage was previously coated. And here you can see that in one plate he got 2, one he got 11, one he got 5, and the numbers are here, and he got 9, and next he got 3. So in different plates which he analyzed here, he got different number of phage resistant E. coli cells. Whereas if you go to consider from this tube, when there was a bulk culture, and from the bulk culture he took again also 200 plates were being checked, and 0.1 ml aliquots of that were being spread onto the phage coated plates, and he found that there was 13, 10, 8, 11, 11. But the difference is when you compare all these 200 plates, the difference was not being found to be that much. That is, there was no much difference, like it was like comparatively similar. But in this plate, in among these, it is probably there was a high fluctuation, and as a result this experiment was also known as the fluctuation test. So now what is the reason behind this? Let's go into this. So of course I mentioned how the experiment. So it was observed that the number of the phage resistant colonies in the 40 independent cultures showed a much greater fluctuation than the number of resistant colonies growing on the plates prepared from aliquots taken from the culture. And this greater fluctuation in the independent cultures was due to the origin of spontaneous mutations arising independently in the 40 tubes at different times. And every mutant multiplied to form a progeny or of resistant bacteria during this incubation period, so that the final number of the resistant bacteria in different tubes were widely variable at the time of the plating. Now, but at the same time, if you go to consider the bulk culture, okay, it had a uniform population of both sensitive and resistant bacteria. And any fluctuation that was observed in the plate from the bulk culture was mainly due to a chance variation. So, there's a wider fluctuation observed in the independent cultures could only he explained by assuming that phage resistance arose due to spontaneous mutations at different types during the incubation at different cultures before the bacteria came into contact with the phage. So let me just explain it here once more for you for your clarification. See, when he observed among these 40 tubes, okay, this is the experiment what he exactly did. I'm not talking about the hypothesis or anything which we kept in our mind earlier. In the original tubes, you can see that in one tube probably these are not exposed, all these 40 tubes are not got exposed to the bacteriophages earlier. And in every tube, now in this some cells got mutated and only 2 cells got mutated, that is forming 2. And in another tube you get 11 resistant E. coli cells, whereas some you get in another tube you get with 5 mutant cells, and this you get 9, and here you get 3. Now what is the reason for this? You do remember that if it is a if it is a random mutation which is happening, the random mutation can happen at different generations. It can be happen at the 2nd generation, it can happen at the 3rd generation, or it can be in the 4th generation. And if based upon the generation in which the mutation happens, the number of resistant colonies which develop would be different. And as we expected in the hypothesis of spontaneous mutation, in his experiment here he is finding that different plates showed different amount of mutations or different number of resistant E. coli colonies. So it was proving that it is mainly because of a spontaneous mutation that resulted in the development of a phage resistant E. coli cell. Now what is this? You might thinking they are having here equal number of cells. So this portion is not having any variation, then why do we say that it is a spontaneous mutation? Now coming to this particular bulk culture, all the cells are together in this. So if you have a particular resistant cell there, that resistant cell will equally divide to form different other resistant cells, and every 0.1 ml of culture which has been taken from this tube is considered to be a mixture of both resistant and sensitive cells. So when you plate them onto different plates, they will get almost a similar number of resistant E. coli cells, because all of them are lying in a single tube. If any mutation happens randomly over there also, they are equally divided in the whole tube, and you get a consistent result over here. Whereas in these tubes, what happens, you have divided them initially itself into different tubes, and if a mutation is happening only in this tube, okay, if the mutation happening here is in the 4th generation, probably you would get only less number of cells. But in this plate, the tube corresponding to this plate, probably what is happening, the mutation is happening at the very beginning, that is might be in the 2nd generation or probably in the 1st generation also, resulting in the formation of more number of E. coli which are being resistant to the bacteriophages. So that is a result that Luria Delbruck came across, and as a result it was being found that the spontaneous mutation theory was accepted, and the induced mutation theory, which was raised by some others against their observations, that was being disapproved. and the Luria Delbruck experiments. Now you might think, what did Delbruck do here? All the mathematical calculations and the variations were being analyzed basically by Delbruck. And if you go to consider these two scientists, you should also remember that Luria's first graduate student was Watson, and this scientist was in fact, with their scientific evidence, they in fact put a dead nail to the Lamarckism, and they also gave a support to the Darwin's theory of evolution. I hope this is clear to you. With this, we come to an end of the Luria Delbruck experiments, which honored them to the Nobel Prize on their work on bacteriophages. Thank you for now.